Alright, now we wish to use our series to solve a differential equation. We're going to use something that we know how to solve anyway, and so let's look at solving y double prime minus 2y prime plus y equals 0, and we're going to say y of 0 equals 0 and y prime of 0 equals 1. Okay, now so I'm going to again define y of x is equal to the sum k equals 0 to infinity a sub k x to the k. Now notice that y of 0 is just a0, right? Because when I put 0 in for x here, the only thing I'm going to have left is the a0 times x to the 0, or a0 times 1. So always on these differential equations, we know that y of 0 is just a0. And then if we define our series the way I just did. Now, we've got our y prime of x, which we now know is the sum k equals 1 to infinity of a sub k times k x to the k minus 1. But again, notice that if you look at y prime of 0, that's just a1. Because again, if I put 0 in for x, any k bigger than 1, x to that, k minus 1 is just 0. So when k equals 1, I get x to the 0, which is 1. But if k equals 1, then I just have a sub 1 times 1, and so I get a sub 1. And then our y double prime of x is our sum k equals 2 to infinity a sub k k minus 1 x to the k minus 2. Okay, so there are our derivatives. We sub those in. We sub those into our differential equation. So y double prime. So we have our sum k equals 2 to infinity a sub k times k times k minus 1 x to the k minus 2. And then minus 2 times the sum k equals 1 to infinity, because this is y prime, a sub k k x to the k minus 1, and then plus y, I think that's right, plus y. So that's just the sum k equals 0 to infinity a sub k x to the k, and then that all equals 0. So there I subbed it in. Now what I want to do is just match up exponents again. And well, I've got k minus 2 and k minus 1 and k, so that doesn't work well. So here I'm going to do my j equals k minus 2. Here I'm going to do j equals k minus 1. And just to make them all j's, I'm just going to say j equals k, so that I'm not really doing anything there. So with the j equals k minus 2, again, this sum, if k is 2 at the bottom here, then j is 0. It still goes to infinity. A to the, now remember, if I solve for k, I get j plus 2, so this is j plus 2, times k is j plus 2, so j plus 2. J plus 2 minus 1 is just j plus 1, x to the j, minus. Now I'll put the 2 on the inside when I do this as well. And again, so k started at 1, but if k is 1, then k minus 1 is 0. So j equals 0 to infinity. I have 2. If k is j plus 1, then this is a j plus 1 times j plus 1, right, if k is j plus 1. And then x to the j. And then here, again, I don't really have to do anything. I'll just make everything j is j equals 0 to infinity of a sub j x to the j, and that all equals 0. Okay, now what we want to do is put all this together. So I've got the sum j equals 0 to infinity of, and a big long thing here. So I have a j plus 2, j plus 2, j plus 1, okay, minus 2a j plus 1, j plus 1, and then plus a j, all times x to the j, and this is equal to 0. So if this is the case that this polynomial is equal to 0, then if it's identically 0, each and every term coefficient here has to be 0. So what I do is I just say, well, if j equals 0, what do I have? I have that a2 times j plus 2 is 2, times j plus 1 is 1, minus 2a1 times j plus 1, that's 1, plus a 0, that has to equal 0. Okay, because that was our first term, a sub j, and if I'm going to get identically 0 for all x, then that had to be 0. So what that means is if I, all right, this is 2a2 minus 2a1 plus a 0, I get 0. Well, so 2a2 is equal to 2a1 minus a0. But remember, I know that a1, what a1 and a0 are. This is 2 times y prime at 0 minus y at 0. And so I get that 2a2 is equal to, let's see, what were those, 0 and 1, I think? Yeah, 0 and 1. So I get 1 for a1, or y prime 0. So I get 2 and minus 0. So finally that tells me a2 is equal to 1, because I get a2 divided by, or 2 divided by 2 is a2. Okay, so at this point, notice that I know a0 is 0. I know that a1 is equal to 1. And I know that a2 is equal to 1. Okay, let's get a couple more. So if I let j equal 1, then, so I just start writing these down. This is a pretty long one, but I just write them down. And so I'll have, if j equals 1, I have an a3. So j equals 1, I've got a3 because j plus 2 here. And then another j plus 2, so that's 3 and then 2. So I'll get times 3 times 2 minus. Okay, I have a minus 2, and if j is 1, I get a2 times 2. So I get minus 2a2 times 2 and then plus, well, that's just my A1. Well, there we go, A1. But that's equal to 0. So again, if I solve for A3, I get 6A3 is equal to 4A2 minus A1. And so if I have that, then I know that A3 is equal to, well, 4 times 1 minus, and A1 was 1, so 1, all divided by 6. I get 3 over 6, which is 1/2. And so I have A0, I have A1, I have A2 here, I have A3. Okay, now more generally I could take this expression and solve for AJ plus 2 in terms of J plus 1 and J. So I'm going to add a page and rewrite what we had there. So we had AJ plus 2, and that was times J plus 2 times J plus 1 minus 2 times AJ plus 1 J plus 1, and then plus AJ, and that was equal to 0. So going back here real quick and make sure that, all right, AJ plus 2, J, yeah, okay, I'm happy with it. I believe it. And so we have this, and if I solve for AJ plus 2, well, that's going to be my 2AJ plus 1 times J plus 1 minus A sub J all over J plus 2 J plus 1. Now, and so remember at this point I had these values, so I had 0, 1, 1, and 1/2. Okay, so let me go back here and write that down, that I had A0 was 0, A1, oops, 0, A1 was 1, A2 was 1, A3 was 1/2. And so now if I go here and I look at A4, so that's J equals 2, A4 for J equals 2 is 2A3 times 3 minus A2 divided by 4 times 3. So again, A2 was 1 and A3 was 1/2, and so on the top I get 3 minus 1, on the bottom I have 12, and so that's 1/6. So A4 is 1/6. If I go for A5, that is equal to my 2A4 times J plus 1. Well, J is, so here J was 0, J is 1, J is 2, J is 2 here, J is 3. So J plus 2, that'd be 5 minus j is 3, so that's a3, right? Oh, j is 3, so I got to be careful there. That's, yeah, j is 3, so I have a4, oh, not 5, but 4. This is j plus 1, minus aj, so a3, all divided by 3 plus 2 is 5 times 4. And so, okay, a4 was a sixth. So I have 2 times a sixth times 4 minus a3 was 1/2. All divided by this 20. And so here, when I have 4/3, 2 over 6 is 1/3 times 4 is 4/3. So in 6, that'd be 8/6. So I need to leave it, I guess, as 6. So 8/6 minus 3/6 is 5/6. So this is 5/6 divided by 20. And that will be 1 over 4 times 6, or that's equal to 1 over 24. I think. Did I get that right? I better write it out here. So that's 5 over 6 times 1 over 20, or 4 times 5. Those cancel. So I think I have 24 there. Looks good to me. Okay. So I believe I have 1 over 24. And so I'm going to stop there. And so what that says is, again, a of 0 was 0, so we have y of x is equal to 0 plus 1 times x plus 1 times x squared plus 1/2 times x cubed plus 1/6 times x to the 4th, and then finally we get up to the a5, so plus 1/24 x to the 5th, and then it keeps going on, and we have to try to discern our pattern there. But I'm not greatly worried about that. I want you to have this basic idea. And so, you know, there's an answer, but actually I did this one. I know what the answer is here. Now notice, if I take an x out of this, what I get is x times 1 plus x plus x squared over 2 plus x cubed over 6. But that's actually 3 factorial plus x to the 4th over, and 24 is 4 factorial. And then it's going to keep on going. Well, actually, you know, what this answer is this is x e to the x. Okay, because this series is this power series is actually the Taylor series of e to the x. And so I knew this answer when I started. I made this problem work this way, where the answer was x e to the x. So generally speaking, you wouldn't, you know, we probably wouldn't be able to discern what this series is, but in nice cases we can. And so this was a nice case because I made it that way. Oh, this says y of 0. Sorry about that. That should be y of x. So y of x is this, And, you know, if I kept going, I would get the right pattern. I would have x to the fifth over 5 factorial and so forth. But this turns out to be y equal x e to the x. And you could go back to the original problem and solve this original problem up here using our techniques with the characteristic equation, you know, r squared minus 2r plus 1 equals 0. Solve that with these initial conditions. And as long as you, quit that. As long as you do it correctly, you should indeed get x e to the x. Okay, so that's an example of how we solve differential equations using these power series.